Imagine you saw this question in the example. What will be your answer? Welcome back to my channel. Today we have an exciting topic to discuss on general gas equation. So let's dive into the class. So basically, general gas equation is a combination of Boyle's law and Charles' law. Remember, Boyle's law has to do with pressure and volume, and Charles' law has to do with volume and temperature. So when you combine the both, that gives us general gas equation, which is what? P1V1 all over T1 is equal to P2V2 all over T2. So this is the formula for the general gas equation. Please, if you have not watched my video on Boyle's law, Charles' law, I'm dropping the link in the description box. Kindly watch the video to learn more. Now, let's quickly get to the questions. But before then, I have important parameters I want us to note. How do you recognize volume? How do you recognize temperature? And how do you recognize pressure? Now, to recognize your volume, volume is measured in cm cube, dm cube, liter or milliliter. Pressure is measured in millimeter mercury, atm, Newton per meter square or Pascal. Then temperature is measured in degree Celsius, degree Fahrenheit or Kelvin. Please, I want us to note these three important parameters. It will help us to identify which parameter is which. Then, when it comes to STP, STP means standard temperature and pressure. What is the value of standard temperature? The value of standard temperature is 273 Kelvin. What's the value of standard pressure? The value of standard pressure is 760 millimeter mercury. Sometimes the examiner may give you the question in Newton per meter square. So in a case like that, the value of the standard pressure will be 1.01 times 10 raised to the power 5 Newton per meter square. So these are the values. Please, it's of importance that you note them. Then the molar volume or the standard volume, the value is 22.4 dm cube. Please note these values, most especially standard pressure at 1.01 times 10 raised to the power 5 Newton per meter square. Many people are not familiar with this second one. Most people are familiar with the first one. Please add this to your catalog of knowledge. Alright, so let's get to the question. Okay, let's look at this question. At STP, a certain mass of gas occupies a volume of 790 cm3. Find the temperature at which the gas occupies 1000 cm3 and has a pressure of 726 millimeter mercury. Please, the first thing to do is to write out your parameters. If you fail to do so, you may mingle up unnecessary values. You may just mingle the values unnecessarily. So let's write out our parameters. Now, it says at STP. At STP. So, at this STP, first of all, what is STP? Standard temperature and pressure. So, at this STP, a volume of this was occupied. So, let's get our values down. So, T1 will be what? Because the temperature was at STP, T1 will be 273 Kelvin. Remember the value I gave us as standard temperature, pressure, and volume. Then P1 will also be what? Let's look at the pressure. Before you write your standard pressure, let's look at the pressure. The pressure is in millimeter mercury. So what will be our standard pressure? It will be 760 millimeter mercury. Then let's look at our V1. Our V1 is what? 790 cm3. Our T2 is what we are looking for because the question says find the temperature. So we are looking for T2. Then our V2 is 1000 cm3 and our P2 is 726 millimeter mercury. So let's now solve using the general gas equation, which is P1V1 all over T1 is equal to P2V2 all over T2. Now let's solve. P1 here is what? 760 millimeter. Please, I want to retaliate. Before you indicate your standard pressure, make sure you know the SI units of the already given pressure. If this was in Newton per meter square, this value will not be here. We only use this value because it was in what? Millimeter mercury. All right, let's solve. So P1 is what? 760 millimeter times V1. V1 is 790 divided by T1. T1 is 273 is equal to P2. P2, where are you? 726 times V2, 1000 divided by T2. That's what we are looking for. So we are going to cross multiply. We are going to have that 726 times 1000 times 273 divided by 760 times 790 is equal to T2. I hope we understood the mathematics I solved. If you cross multiply, this is going to be the coefficients. This is going to carry the coefficients. So what do we do here? Let's multiply. 726 times 1000 times 273 is equal to 198,198,000 divided by 760 times 790 is equal to 600,400. So you have that 198,198, 1,000 divided by 600,400, and that will give us 330.109. So we're going to leave our answer in three significant figures, and that will be 330. Our temperature is in Kelvin. 330 Kelvin is equal to T2. Isn't that simple? Let's solve another question. Okay, let's look at this question. A given mass of a gas is 0.12 gm cube at 1.01 times 10 to the power Newton per meter square pressure at 60 degrees Celsius. If the temperature is changed to 90 degrees Celsius, find the pressure at a volume of 0.24 dm cube. Very simple. So the first thing to do is to write out our parameters. So this is what? V1 dm cube, 0.12 dm cube. Then this is what? Pressure, P1, 1.01 times 10 raised to the power 5 Newton per meter square. And at T1 is 60 degrees Celsius. You are going to add 273 to convert it to Kelvin. And that will be 60 plus 273 will give us 3333 Kelvin. Then if the temperature is changed to 90 degrees, so T2 is 90 plus 273, and that will give us 90 plus 273. That will give us 363 Kelvin. Find the pressure. So we are looking for pressure. P2 is what we are looking for at a volume of 0.4 dm cube. So V2 is 0.24 dm cube. So let's solve using our formula. P1V1 over T1 is equals to P2V2 over T2. So you have that P1 is what? 1.01 times 10 raised to the power 5 times V1 is 0.12 all over T1 is what? 3333 is equal to P2. What is the value of P2? P2 is, that is what we are looking for, times V2. V2 is 0.24 divided by T2. T2 is 363. So you're going to cross multiply, and that will be 1.01 times 10 raised to power 5 times 0.12 times 363 divided by 333 times 0.24. So this is equal to what? P2. Are we together? So let's punch our calculator. 1.01 times 10 raised to power 5 times 0.12 times 363 equals 4399560 over 333 times 0.24, and that will give us 79.92 is equal to P2. So we are going to divide the both. 4399560 divided by 79.92, and that is going to give us 55049.54955. We are going to leave our answer in the nearest whole number, and that will be, so add 1 to this, it's 10, add 1 to this, it's 5, 55050, which is 5.5 times 10 raised to power 1, 2, you count 1, 2, 3, 4, times 10 raised to power 4, which is 5.5 times 10 raised to power 4 Newton per meter square. Answer, because the value of our pressure was given in Newton per meter square. Answer. Isn't that simple? Okay, I'm going to give you a question to solve. Please kindly put down your answers in the comment section. All right, so this question is for you. The question says 160 cm cube of a gas at 20 degrees Celsius exerts a pressure of 760 millimeter mercury. Calculate its pressure if the volume is increased to 150 cm cube at 50 degrees Celsius. So this question is for you. Now write down your parameters, solve the question, and drop your answer in the comment section. Thank you for watching. Please do well to subscribe to our channel. Invite your friends as well to do the same. Thank you and bye.